here is your quiz review for your quiz that's tomorrow. All right, it's over solving nonlinears, and it's also over partial fraction decomposition. So what is important for you guys to remember and to know and to understand? It's solving nonlinears and partial fraction decomposition. What we've done the last few days is not going to be on our quiz. We're going to work more on it Friday, Monday, Tuesday, just so we can make sure that we have everything under control of what we're doing. But a good thing for you to review, in addition to this video, would be the College Algebra Trig, CAT, Senior Final Review. The answers are uploaded on Canvas in their modules, and there's also a review video on YouTube. That's extra of this stuff, so you know exactly what you're looking for. So if you come to something like this, all right, there's a bunch, a bunch of different ways that we can solve all of these problems. But what is probably the easiest way to attack a problem like this? What do you think? Sub in y? Yeah, it's already set to y equals something. So I'm just going to take this whole expression and plug it in right there. So we have x plus 2. Instead of y, I'm going to write x squared minus 2x minus 3 equals negative 4. What do I do now? Distribute the 2. So I have x plus 2x squared minus 4x minus 6 equals negative 4, correct? Now this is a quadratic, so we're going to have to go through and combine like terms, move everything to one side. So do I have anything else that has an x squared? No, so I'm just going to rewrite my 2x squared in front. I have a positive x and a negative 4x, which gives me what? Good, minus 3x. And then I have this negative 4 over here. If I move it over here, I'd have to add 4 to both sides, right? So what's negative 6 plus 4? Negative 2, and then we have equals 0. Now this is just a factoring problem that you guys have done a million times. I'm going to multiply my a times my c. 2 times negative 2. Are there factors of negative 2 that could multiply to give me a negative 2? This is 4. I don't know why I said that. Is there factors of negative 4 that would multiply to give me a negative 4, but add to give me a negative 3? Negative 4, positive 1. Good. Negative 4 times 1 is negative 4. Negative 4 plus 1 is negative 3. And since my a term is not 1, I have to put it underneath our two factors. 4 divided by 2 is 2, so this works out to x minus 2. 1 divided by 2 isn't pretty, so this becomes our coefficient, 2x plus 1, and both of these equal 0. So now we can solve for x. If I set each parenthesis equal to 0, I get x equals 2 here. And if I move 1 over, it becomes negative. Divide by 2, I get negative 1/2. You guys agree with me on that? So now I'm going to take those two values and I'm going to plug them into one of our original equations and figure out what y equals. So which one would be easier for us to plug into? The top one or the bottom one? The top one. X plus 2y equals negative 4, right? So x plus 2y equals negative 4. X plus 2y equals negative 4. So I'm going to plug in my x. I have 2 plus 2y equals negative 4. I'm going to minus 2 from both sides. I get 2y equals negative 6. Divide by 2, and I get y equals negative 3. Agreed? So when I plug in positive 2, I get out negative 3. What can I do with that answer to make sure that I'm right? I can plug it back in. We could definitely plug it back in. Now we're going to do the exact same thing over here on the right-hand side. I'm going to plug in now negative 1/2. So negative 1/2 plus 2y equals negative 4. What's another way I can write the whole number negative 4? If it's negative 4 over 1, how can I write it with a denominator of 2? If I made this into seconds, I'd multiply 1 times 2, right, to give me 2. So 4 times 2 is be negative 8. You guys agree with me? Okay, we're going to do that just to make our math a little bit easier here, because I'm going to add 1/2 to both sides. So if I add 1/2, I get 2y equals, what's negative 8 plus 1? negative 7, right? Negative 7 over 2. Now I'm going to divide both sides by 2. So y equals, this is negative 7 over 2. If I keep change flip, what happens? Negative 7 over 2, I'm going to keep, I'm going to change, and I'm going to flip. It becomes what? 2 over 1 becomes 1 over 2. So I get negative 7/4. So when I plug in negative 1/2, I get out negative 7/4. And again, what can I do with that answer? Plug it in to make sure that it's right. All right, look at this one. I want you to really look at this problem. This could get super duper messy, right? Say I wanted to solve the top for x. I'd have to move y squared over, and then I'd have to take the square root of everything and then plug that in. That could be a mess, right? Yes or no? What do you guys notice about this equation? Or both of these equations? Say I didn't want to use substitution. Can I use elimination here? How come? I could multiply the top by negative 2. Good. Do I even have to do that? The y's, right? The y's are already exact opposites of each other. So if I use elimination in this case, obviously we're not going to use elimination in this one because it's not set up that way. But here, if you notice, oh my gosh, look how easy is this. I can get my y squareds to cancel out when I combine them. This is 1x squared plus 2x squared gives me 3x squareds, right? And then what's 9 plus 3? 12. How do I get x by itself? Divide, great, both sides by 3. So x squared equals 4. I don't care what x squared equals, I care what x equals. So what's my answer here? What do I do? Square root on both sides. So x equals what? Yes, very good, Raul. Plus or minus 2. X equals positive 2 and x equals negative 2. So now I take those two answers and I'm going to plug them in to one of my original equations. Which one looks a little simpler? The top one, right? X squared minus y squared equals 3. So x squared minus y squared equals 3. X squared minus y squared equals 3. So plug in your x. You have 2 squared minus y squared equals 3. 2 squared is 4. And I'm going to subtract 4 from both sides, right? So I get negative y squared equals negative 1. Do we like our variables to be negative? Yes or no? No. So we're going to divide both sides by negative 1. So I get y squared equals 1. Now what? Square root. Great. So y equals plus or minus 1. I have two answers here. When I plug in positive 2, I can either get positive 1 or negative 1. You guys see that? What can I do with those two answers? Plug them back in to make sure I'm right. Good, 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 good. All right, now I'm going to scoot over here. I'm going to do the exact same thing, but we're going to plug in negative 2. So I have negative 2 squared minus y squared equals 3. Well, what's negative 2 squared? 4. Subtract 4 from both sides. I get negative y squared equals negative 1. Divide both sides, good, by negative 1. So y squared equals 1. Square root, y equals plus or minus 1. So in this case, y'all, when I plug in negative 2, I get positive 1, and I also get negative 1. So how many solutions are there to this set of nonlinear equations? 4. That means if you graph these two equations, they would cross 4 different places. They'd intersect. Questions at home? How we doing? We okay? Okay, 2 more. What do you want to do? Which one looks a little simpler? The bottom one. So what do you want to solve for, x or y? Y? Okay, so I'm going to divide both sides by x. Right? So everywhere I see a y, I'm going to plug in that. So 2x minus, instead of y, I'm putting 4 over x equals negative 2. All right, we have a denominator. Doesn't matter if it's a letter or a number. We have a denominator and we don't like it. So what can I multiply everything on both sides of the equation by to make my denominator go away? It can be a letter or a number. Yep, perfect. X times 2x is 2x squared. If I multiply 4 times x, I get 4x, right? Then what happens to the x's? They cancel out. So I have minus 4, and then I multiply x times negative 2, so I get negative 2x. Here is our basic quadratic, guys. Let's move everything to one side. So I have 2x squared plus 2x minus 4 equals 0. Now we're going to factor. You guys notice anything? Okay, perfect. Take out a 2. I'm left with x squared plus x minus 2 equals 0. Are there factors of 2 that will multiply to give me a negative 2 but add to give me a positive 1? Perfect. Plus 2 minus 1. Good. Now set each piece equal to 0. Guys, 2 equals 0. Is that ever a true statement? Nope. So it doesn't work. If I solve the first parenthesis, I get x equals negative 2. And if I solve the second parenthesis, I get x equals positive 1. Agreed? Yes? No? Okay. So we're going to take our two answers and we're going to plug them in. Which equation is the easiest? They're both fairly easy, but which one do you want to use? xy equals 4? Okay. xy equals 4. xy equals 4. Good job. So in the first case, I'm going to plug in negative 2. So I have negative 2y equals 4. Divide both sides by negative 2, and I get y equals negative 2. On the right-hand side, I'm going to plug in 1. So 1y equals 4. Well, that's simple. Y equals 4. So over here, when I plug in negative 2, I get out negative 2. On the right, when I plug in 1 for x, I get 4 for y. All right, I'll post all of this when I'll post the video, but I'll also post the answers all worked out so you guys can practice it and stuff tonight. All right, now what? This one's a little more difficult because we got some squareds, but what do you want to solve for in the bottom equation, x or y? Okay, you want to solve for x. Perfect. So I'm going to divide both sides by y. So everywhere I see an x, I'm going to plug that in. So I have 2 over y squared plus 2y squared equals 6. This 2 goes to the numerator and to the denominator, correct? So 2 squared is 4 over y squared plus 2y squared equals 6. Now remember, guys, there's a denominator here of 1. If I'm going to get rid of that denominator, what am I going to multiply the entire equation, left-hand side and right-hand side, by? Y what? Perfect. Good. Very good. So when I distribute here, the y squareds will cancel out, left with just 4. 2y squared and 2y squared gives me plus 2y to the 4th. Y squared times 6 equals 6y squared. Let's move everything to one side. So we have 2y to the 4th minus 6y squared plus 4 equals 0. Now before we go ahead and try and find a times c and all that stuff, what can I take out? I can divide out a 2 from everything. So I'm left with y to the 4th minus 3y squared plus 2. Everybody agree with me? All right, now we can factor. I have 2 on the outside here. What times what gives me y to the 4th? Perfect, y squared. So y squared here, y squared here. Now what are the factors of positive 2 that multiply to give me a positive 2, but add to give me a negative 3? Negative 2 and negative 1. Good. So set each piece equal to 0. 2 equals 0. It's not true. Y squared minus 2 equals 0. Y squared minus 1 equals 0. If I move 2 over, this becomes y squared equals 2, right? So what does y equal? Plus or minus square root of 2. All right, no big deal. You got a square root, no big deal. Here, I move the y over. I get y squared equals 1, square root. I get y equals plus or minus 1. So in this case, I have 4 answers. Y equals the square root of 2. Y equals negative square root of 2. Y equals positive 1. And y equals negative 1. Now go back to the very beginning. What's the easier equation to work with? xy equals 2. Okay, so I have xy equals 2, xy equals 2, xy equals 2, and xy equals 2. So I have x times the square root of 2 equals 2. I want to get x all by itself. So I'm going to divide by the square root of 2. Agreed? So x equals. Guys, can you leave the square root of 2 there? No, we have to rationalize. This becomes root 2 over 2. So this becomes 2 root 2 over 2. What happens? What do the 2's do? Good, they cancel out. So I get the square root of 2. So when I plug in x is the square, when I plug in y is the square root of 2, I get out x is the square root of 2. Be careful here, guys, because we plugged in a y value. We started off with a y. Very easily you could plug in or say, oh, that's x equals. And it's not. We plugged in y, so that's the second value in our ordered pair. So I'm going to go over here and do the exact same thing. So now I have x. It's negative x, actually, because it's times square root of 2. Negative square root of 2. What am I doing? Equals 2. So divide by what? You want to divide by the negative square root of 2 here to make it positive? That's fine. Same exact problem, guys. X equals. Can I have square root on the bottom? No. So rationalize. This leaves me with 2 root 2 over negative 2. So this cancels out and just becomes negative square root of 2. So your x value is negative square root of 2, and your y value is negative square root of 2. Those are the hardest kinds of problems because it's a square root. This one's super easy. If I plug in 1 for y, x times 1 equals 2. So x equals 2. So my ordered pair is 2, 1. You got that one? So x times negative 1 equals 2. So negative x equals 2. Divide both sides by negative 1, and x equals negative 2, right? So negative 2, negative 1. That's probably the hardest kind of problem that you guys will see. It's not easy. I understand that. Scooting along. Where are we? All right. Partial fraction decomposition. Some of these we're going to set up and solve. Some of these we're just going to set up. So you guys have to pay attention to what the directions say. Sometimes the directions won't specify, but you can tell, since it's multiple choice, you can tell what they're asking you to do in the problem. Whether they're asking you just to set up so you have your ABC, or whether they're asking you to actually go ahead and solve. So these first ones, they're just asking us to set up. It says do not solve. So the first thing we have to do when we have our partial fraction decomposition is to factor the denominator. So can I factor this denominator? Are there factors of negative 15 that'll multiply to give me a negative 15 but add to give me 14? Plus 15 and minus 1. Perfect. So how many pieces am I going to break this up into? 2 pieces, right? I have 2 different things in my denominator. So I have x plus 15 and x minus 1. Does not matter if you put x plus 15 first and x minus 1 second, or if you switch them. Does not matter. I'm going to put an A here and a B here, and we're done. That's all you have to do for these ones is set up. This is your setup. We're going to go through and solve one here in just a minute, but this is your setup. Questions? Is that all right? Okay. Look at the next one. First thing I have to do is factor the denominator, right? So this becomes x. What does x squared minus 4 factor into? Awesome. X plus 2, x minus 2. So how many pieces here do I have? 3. 3 different pieces. I have x as a denominator. I have x plus 2 as the denominator, and I have x minus 2 as a denominator. So how many numerators do I have? 3. I have an A, I have a B, and I have a C. And that's it. This is just the setting up part. You don't actually have to solve it. In a second, like I said, we're going to go through and solve. All right, let's look at the last one. How's this one a little different? We've done a couple of these, but how's this one a little different? Because we got a cube. So remember, we have to account for x plus 3 to the first power, x plus 3 to the second power, and then to the third. So I actually have 4 pieces here. I have my, is it x minus 1? Yeah. And then I have a piece that is x plus 3 to the first power. Then I have a piece that is x plus 3 to the what? Second power. And then I have a piece that is x plus 3 to the what? Third power. So how many variables do I have on top? I have an A, I have a B, I have a C, and I have a D. If we were to actually solve this one, this would be a long problem, but I'm not going to give you one like that. Here we go. We're going to do one of these. Again, if you look on Canvas, under modules, and I'll show you here in a second, you have all the senior final stuff that they worked on. All of it worked out there for you to practice. There's also a YouTube video that you guys can watch for extra practice. But we're going to not only set this up, but we're also going to solve here. So it's going to take a little bit of time. We need to work through this, make sure you guys are paying attention to what you're doing. But I have to first factor the denominator. So if I factor here, 2 times negative 15 is negative 30. What are the factors of negative 30 that'll multiply to give me a negative 30, but add to give me 7? Yes, plus 10, negative 3. Since a is not 1, we're going to divide both the factors by 2. So I have x plus 5 and 2x minus 3, right? Okay, let's go one step ahead. Let's go ahead and solve. I'm going to use x equals negative 5, and I'm going to use x equals 3 over 2, correct? If I move the 3 over, it becomes positive, then we divide. All right, so I have 2 pieces that I'm going to set this up. 2 pieces of a denominator. My first piece is going to be x plus 5. My second piece is going to be 2x minus 3. Again, you guys, it doesn't matter. If you put 2x minus 3 first, that's fine. But I have my a here and my b here. So this part of the solving, right, there's the setup. Here's the solving part. I have to say each fraction, I got to look at it individually, and I have to say, okay, my first fraction has the x plus 5. What piece is it missing from the other denominator? The 2x minus 3. So then on B, I have the 2x minus 3. What piece is it missing? The x plus 5. And now we have an equivalent statement that we can write down and then plug in our 2x values. So we have negative 4x plus 7 equals a times 2x minus 3 plus b times x plus 5. So I'm going to evaluate this twice. On the left-hand side, I'm going to use x equals negative 5. And on the right-hand side over here, I'm going to use x equals positive 3 over 2. When I plug one of these in, what should happen to the other variable? Good. So I have, let's just plug in, negative 4 times negative 5 plus 7 equals a times 2 times negative 5 minus 3 plus b times negative 5 plus 5. Agreed? Okay. So negative 4 and a negative 5 is 20. Plus 7 gives me 27. Agreed? Okay, on the right-hand side, 2 times negative 5 is negative 10, right? Minus 3 gives me what? Negative 13. So I have negative 13a. And then what happens with negative 5 and a positive 5? It's 0. 0 times b just cancels out. Good. So in this case, guys, I'm going to divide both sides by negative 13. And a equals negative 13 over 27. Doesn't simplify to anything pretty. Just leave it. It's fine. Now over here on the right-hand side, we're going to do the exact same thing, but we're going to plug in 3/2. So negative 4 times 3 over 2 plus 7 equals a times 2 times 3 over 2 minus 3 plus b times 3 over 2 plus 5. Working with a fraction, that's okay. You guys can handle it. If I cancel out here, this becomes negative 2, right? Negative 2 times 3 is negative 6 plus 7. What's negative 6 plus 7? 1. Here, the 2's will cancel out, then 3 minus 3 is 0, so what happens to the a? What happens to a? Yep, cancels. All right, let's do a little math in our head over here. If this is 5 over 1, how could I write it as a denominator of 2? 10 over 2, good. So we can look at it like that. What's 3 plus 10? So I have 13 over 2 equals b, right? So if I'm going to get b by itself, I divide both sides by 13 over 2, correct? So b equals, if we keep, change, and flip, this becomes 1 times what? 2 over 13. So b is 2 over 13. Are we done? Ish? Kinda? We close? Oh, guys, look how I wrote this. I wrote it upside down. You see that? This should be 27 over negative 13. So, a is 27 over negative 13, right? Over x plus 5. Plus b is 2 over 13 over 2x minus 3. What's a different way I can write that so it's a little prettier? Where can I put the 13s? On the bottom. They're in the denominator. So this is really negative. I have 27 over 13 times x plus 5 plus 2 over 13 times 2x minus 3. And there is your answer. Long problem. I understand that. It's a long one, but that is it. So your quiz tomorrow is going to encompass, again, I'm telling you, not solving nonlinears and partial fraction decomposition, setting it up and solving. Probably 10, 12 questions, something like that. You guys are not going to have the whole class period, so you'll have plenty of time to log in. People in here, you're going to take it on the iPad as well. Yes, sir.